Hi, my name is Christopher Brown. Welcome back to Easy Breezy Math, Math Tips for Teachers. In this video here, what I wanted to do is show you guys a way to do distance between 2 points without using the distance formula. Now, in order to do this properly, we want to have a good understanding of the right triangle theorem or the Pythagorean theorem because it's the exact same concept you'll notice as the distance formula. This is what we want to really do in math is we want them to be able to link these different concepts together and see the relationship between them and how they relate to all the math and how it's really all related and interchangeable almost. So this here is what I have on the board of where I'd like to start off with. Again, you can't do this unless you make your own sheets and give your own assignments to your students. This is something I really encourage you to do. You need maybe a little stencils, your rulers, and to get your lines straight and everything. But once you begin to do this, it changes everything in your classroom. It's almost revolutionary. The changes that you'll see in your students, how much they enjoy the lessons, and also how much you'll enjoy teaching them because they'll understand it. And when you understand math, it is fun. All right. So let's begin. So here I have the distance between 2 points, and it just starts off with a real simple, what's the distance between A and B? Now, if you'll notice, I have my numbers here, -5 and 4, 3 and 4 there. So they both have the 4 in common. There's no real difference between those two, so we won't really look at those. We need the difference between the -5 to the +3. So what we'll do for that, we want the difference between them, we always subtract. In this time, when we subtract, we're going to use our always positive signs. That's right. I like to call these the always positive signs. Why? Because that's what they mean. So when I first introduce them, I'm going to say always positive signs. Later on, we can talk about, oh, it means absolute value is another word for always positive. But right now, I like to go right into the definition of the word so there's no blockage and they don't have to stop and think, what does absolute value mean? No, they're always positive signs. Okay. So this is a party or war. Please reference my party versus war videos. In this case, you have -5 and -3. Are they going to party or are they going to war? And that's right. These two will probably party, which means what happens at a party, everybody comes together. I get -8, but since it's always positive, I will get 8 for the distance between A to B. I'll just put a little 8 in there as well, so that I'll keep that up for later reference. And then we need from B to C. The -5s are the same. So I need the distance between -2 and 4. So -2 minus 4, again, always positive signs. And I'll end up with -6 or +6. And there we have that. So I'll put my little 6 there. Okay, the distance between C and D, -5, -2, 1, and -2. The -2s are the same. I need the distance between -5 and -1. So again, that looks like it will again be 6. So then I'll write the 6 in here for later reference. Okay. Then I need the distance of line DE. Line from D to E, the ones are the same. The -2 and the -5 are the ones I need to subtract. So I need a -2 minus a -5. Okay. Usually by now they know whenever they see that to change it to positive. So I have a -2 plus 5. -2 plus 5 is at a party or a war. And you might want to, again, reference my party versus war videos, and you'll see that's a war. Who wins a war? Negatives or positives? It looks like positives win, in this case, by 3. So we'll end up with a +3 or just a 3 there. Absolute value would have made it positive anyway. Okay, so those are the basic lines. I have all my lines there. I have the distance between each one. Now, what I want to do is get to the fun part. Notice what it says here. I need to find the distance between points A and C. Okay, I don't have a line there, so let's pretend there is a line there. And notice now what have I formed with this? This is now my right triangle. So I have a right triangle, and according to the right triangle theorem, I know that 8 squared plus 6 squared, if I add those together, it will give me the squares for the third side, and then I just have to find the square root or how many are along the edge of that square. Okay, so 8 squared is 64. 6 squared is 36. I'll add that up. And what I do, I'll get 100. What's the square root of 100? there's 100 squares and the square on the outside, I know the square root of that is 10. And I've just found the distance between A and C without having to go to the distance formula. Okay, so let's look at B to D. B to D, I'll draw my little dotted line there. Okay, I have a 6 by 6, and there's my right triangle. Okay, so if I could even pull that triangle out if I wanted to and have it as a 6 by 6, just like that. And I want to find the hypotenuse or the side opposite the 90-degree angle. 36 plus 36, right? What is 36 plus 36? Well, I'll do that to the side real quick, and we should know that that's going to be 72. So I'll have it as square root of 72. I know that's not going to be 72, right? I can't have 6, 6, and 72. I have to have the square root of 72, which we know is somewhere in between 8 and 9, right? Because 8 squared is 64, 9 squared is 81, and 72 is somewhere in between there. We want to talk about those, have those conversations, ask those questions in class. You always want to be checking for understanding, right? Okay, let's see. The last one is line C to E. So from C to E is there to there. I'll go ahead and draw my little dotted line. I have another triangle with that is a 6 and 3 for my straight legs. They call them legs in the book, but it's just one side and the other side, and across is the third longest side, which is the hypotenuse. I like to call it the longest side so we understand that that's part of what the hypotenuse is in the triangle. It's the longest side. So that's going to be 36 plus 9. 36 plus 9 is 45. So I'll just put my 45 here and say the square root of 45, that would be the distance from C to E, which again is somewhere in between 6 and 7, a little closer to 7 and 6. And we want to have those conversations. We'll talk about them. I'm not going to write the other things, what those could be. You can do that later on a calculator. What I want you to be able to do is just get a good idea of how to teach this distance between 2 points without even having to go to a formula. Okay. This is actually a more fun way to do it. It's a way that they're going to understand because right after they do the Pythagorean theorem, things like this are going to be fun when they can just find the points, the distance between 2 points without having to try to remember distance equals the square root of the x's minus and plus in the middle and squared. Writing all that stuff out, that can be very laborious. And when we learn to do it in our heads, we understand it, and it just makes the math go much more fluid and much more smoother. That's what we want to do. Okay. So if you like this video, you want to try check out some more of my videos where I go ahead and explain the math without the formulas. When we take the formulas away, we get a deeper understanding of what's really going on. And that's what makes students want to go to higher math and continue to do well in math. Okay. So this is Easy Breezy Math. Go ahead and like the video if you did. Subscribe if you didn't like it. Go ahead and tell me why in the comments, and I'll see you later on the next video. Thank you.